Second is mobile AR. I'm going to show you two applications of mobile AR. Then you will see that this is a project that's a little bit futuristic, but everyone is talking about. Here's the first application, gaming. I think I don't have to introduce it. There's a game called Pokemon Go that was actually promised being an AR game. Okay, but as we're playing it, it's not exactly that immersive yet. Okay, what people are imagining more immersive as an AR game, Pokemon as a more immersive AR game should look more like this. Okay, when you hold your smartphone up and turn the camera on, you want to be able to see these game landmarks, okay, being overlaid and embedded in the physical background. Okay, so that creates an immersive experience and increase the fun factor of the game. Similarly, I think in the game you can also configure such that you have a pet Pokemon, your favorite Pokemon following you all the time, but you don't get to see it really in the game. How about this? Okay, when you have your phone up, you could turn on the camera and then you can shoot your friend and his favorite Pokemon following him or even interacting with him. Navigation is the second application. This one is also nicknamed the killer app of mobile AR. Now, let's focus on this picture on the left. This is vehicular navigation. Well, it's not real yet, but this synthesized picture is to demonstrate, to show that when mobile AR is mature, what we can see, okay, life gets more convenient and easier. So let's assume that we are the one driving, okay. We can see from within the car right on the windshield, okay, where, hey, our attention is still on the road. We see that the car in front of us is really close, only 20 meters away, and we are driving this speed, within the speed limit, but we do need to make a turn in about 75 meters. Now, given the present state, we see roadblock on the right, don't go, but the lane on the left clear. So the navigation system can suggest just make a left, bypass the car in front of us, right? And when the turn is coming, we can also lay out the hints and point to the exact turn that we need to make. See, a lot more convenient and a lot less stressful, okay, driving. Similarly, this is a human navigation. Okay, imagine you're walking in Shinjuku Station, for example. There is a huge and complex underground structure. It'd be really convenient if you can raise your phone and see exactly the navigation system point the direction and laying over the physical background. And that makes it a lot easier to understand where you're supposed to go instead of finding out exactly what direction, okay, this should be and that should be. If you thought that holding up your phone and looking into it like this is not exactly convenient and a little bit stupid, yeah, these AR glasses, they're coming. Okay, Apple has announced that their Apple Glass will be available the end of 2022, but I guess they might delay this to 23 or 24 depending on how they get the parts in from the manufacturers. But our own HTC, with 15,000 NT dollars, you can already purchase HTC's AR glass. It's called the Vive Flow. So I have not yet tried it out myself, but if you know, let me know. Okay. So there are several companies selling the AR glasses already. In our experience using these smart something hardware these days, we see we somehow have the ability to make it smaller, lasting longer, and working better. So in the near future, it will be more mobile AR in a seamless way without the need of holding up the phone. Now, let me show you something that we did to demonstrate how we moved one step closer to real mobile AR. So in this demonstrator, we set up a mobile client, an embedded system with a camera. And there's a backend server. I call it the edge server. It's connected to the internet that allows the mobile client to take video from the camera and stream that video to the server. The server here is processing and find out what the physical environment is, okay, and do some computation, and then overlay some virtual hints or virtual landmarks onto the video, and then stream the augmented video back to the mobile client and show it on the mobile client's display. So Here on the left, at the client, we take live stream from the camera and then we play back the augmented stream. Over here at the edge, we do object detection on the video that we received, and then we render the virtual object on top of the video and then transmit that video out. Okay, so this is Polly in her office. Teddy here is the best friend of Pikachu. So when Teddy is in Polly's office, Pikachu shows up. Now, Polly removes Teddy from the office and Pikachu goes away. And please do excuse Polly being excited because she hacked the whole thing through a semester and it's finally working. So you see in that simple demonstration, it's working. But when there are more people using the system, you can imagine the delay grows longer and it will no longer feel like it's real time. Okay? And here's to explain why. Okay? When more people are using it, the delay gets longer. So the whole process is this. Okay, the camera here taking video and it's going to be streamed to the server. Server will need to decode the stream and then put it into a buffer, and then the object detection module will take frames out of the buffer one at a time, do the object detection, and then overlay the virtual object accordingly, and then encode these frames into the augmented stream before the stream can be sent back and rendered on the display. So every single one of the steps will take time. So this is a network delay, T1, to stream the video to the server. There's also T2 to do the object detection, because there's an object detection model behind that's trained, okay, from taking a lot of data with a lot of labeling effort. And then T3, this is computer graphics. You will need to render a virtual object on top of a video frame. Okay? And really depends on how much detail you want on the virtual object and how vivid you want it looks like on the video frame. It might also take a long time. Similarly, to stream the augmented video back, T4. So T1, T4, network delay. T2, T3, significant computation delay. So this is a project that's multidisciplinary by default. Okay, that would require computer network person, a computer vision person, and computer graphics person to work together to try to shorten the overall end-to-end delay. To point out the challenge of building a mobile AR system, let me show you this. Okay, so this is a Pokemon Go game event called Safari Zone, where you have tens, thousands of players gathered in a park, a small area like this. Now imagine each one of them wear a glass and transmitting video or receiving video from the server. Yeah, so there's a bottleneck doing the video or image transmission, as well as the server there doing computations to detect objects in the physical environment, and to what? Render and overlay virtual objects. And so you can imagine yourself now working in toy projects in mobile AR. One is to reduce T1, for example, reduce the resolution, reduce the frame rate, or do some pre-processing to reduce the size of each frame so that we reduce the amount of bits we need to send, and therefore reducing T1. Now one can also try to think of ways to reduce T4, and one example, instead of sending the full augmented stream, one can probably just send where we want to render what object, right? And so that we have the client doing the rendering of the virtual objects on the original frame. That will save us from sending a lot of video bits, okay, over the internet on the way back. One can also think about developing models that will fit the best for the application. So that will involve building object detection models that allow us to do fast lookup, fast detection. That will involve also one does object detection such that it will still work correctly with low resolution, low frame rate. Rendering, I think this is one of the hardest topic. So one can also work on building object detection model that works just as well for low resolution video, low frame video, or videos that are being compressed in a sort of context aware way. One can also work on planning a CDN, or I call PDN, process distribution network, so that the object detection part of the server can be load balanced. Now, of course, one can also be working on rendering virtual objects, okay, algorithms to render objects, especially animated objects on the original videos. And this can be done here at the server, or one can consider doing it at the embedded system, the client end. A word of caution for students who are interested in the project. You see that the scope is quite big, even though the idea is very simple. So you see that it does require students who are familiar with system programming, first of all, who are familiar with video streaming, who know computer networks, and who have experience doing computer vision as well as computer graphics. So if you can assemble a team of students who have diverse expertise, that will work the best.